Nevada is a state where farming has always been tough, at the very least because over 110,000 square miles of its land is more than 70% desert and semi-desert, mainly the Great Basin and the Mojave. But locals try to make it work. Irrigation systems are built that let them grow certain crops even in these conditions. The problem, however, is that irrigation, even with the purest fresh water, means salt buildup in the soil. In other words, while adapting to the environment, the state's actually making things worse. Now imagine that, on top of that, Nevada residents are adding salt to the soil themselves for a really strange purpose: to attract bees. Millions of unique bees. Why? Without this, Nevada would lose out on millions of dollars in profit and could even risk a huge chunk of its current agriculture. Well, that's the short version. Let's dive into the details. Nevada doesn't look like an agricultural paradise, yet there's still something that's grown really actively here: alfalfa. This is a crop that's mainly used to feed livestock. According to 2024 data, alfalfa was grown on 220,000 acres in Nevada, and if that doesn't sound like much, let's compare it to corn and wheat. The first crop, according to the same 2024 data, was grown on just 17,000 acres, and wheat doesn't even appear in the state's annual reports as significant in terms of area. Its share compared to corn and especially alfalfa is minimal. The conditions in Nevada are the same for all of these crops, so why choose alfalfa instead of wheat or corn, which are primarily needed to feed people rather than animals? First of all, alfalfa's roots can go as deep as 33 feet to find water, making it exceptionally drought tolerant. Moreover, being a legume, alfalfa naturally enriches the soil with nitrogen. In the dry conditions of Nevada, this helps restore the land's fertility, cutting down the need for expensive fertilizers. And besides, farmers obviously wouldn't pick alfalfa if it didn't make money. The thing is, unlike corn and wheat, it's a perennial crop that yields several harvests per season, which in turn makes alfalfa very productive and profitable. Seeds add value to alfalfa, so some farmers specialize in growing the crop just to sell the seeds, which are then used to grow feed for livestock elsewhere. According to some reports, alfalfa hay sells for $160 to $340 a ton, while seeds go for around $10,000 to $14,000 for the same amount. Overall, farmers in Nevada definitely need to focus on growing alfalfa in a way that gets them both hay and seeds. However, in this case, there's a serious problem. The petals of alfalfa flower are arranged so that the part with the pollen is under tension, hidden inside the lower petals. For all of it to be released, an insect needs to press on these petals, after which they straighten out and the pollen shoots out onto the visiting pollinator's body. Then it carries the pollen to another flower where fertilization happens and a seed eventually forms. Honeybees and other common pollinators can't always handle this special task. They can collect nectar without triggering the mechanism or move around in a way that gives a little cross-pollination. In the end, field observations and studies show that just putting out hives doesn't boost alfalfa seed yield. For this reason, Nevada and its farmers need to look for other ways to pollinate alfalfa. At this point, salt suddenly comes into play. It's needed so that other pollinators, which do the job really well, can thrive in the area. This is the bee Nomia melanderi, a native species of North America found across parts of Canada and the western U.S. This species has been around for a long time in what's now Nevada, like in the Great Basin, that dry stretch of land that's challenging for agriculture and for lots of animals. In the mid-20th century, the population of this bee took a sharp hit because of insecticides and habitat loss. But, for example, in Nevada, people realized at some point that alfalfa pollination depended on that species, so farmers started running local projects to help get the hardworking insects back onto the fields of this valuable crop. What's salt got to do with it? The thing is, Nomia melanderi is a unique species that lives very differently from the honeybees we're used to. They lead a solitary life, and each female builds her own home without forming large colonies. Members of the species make their nests under the ground, excavating vertical tunnels 6 to 16 inches deep, and also carve out horizontal offshoots where food is kept and the larvae stay. Meanwhile, they require damp, clay-rich soil that's well-drained and rich in salts. This environment offers a perfect space for their young to survive and develop, since the salt helps hold moisture and protects the nests from mold and other soil-dwelling pests. Knowing this, people started attracting bees to areas near alfalfa fields, creating so-called bee beds. First, farmers pick a suitable piece of land, usually a flat, sunlit spot that has good drainage. Then they prep the soil. loosening it, and getting the right consistency to make it easier for bees to dig their burrows. After that, salt comes into play. It's spread over the surface, forming a thin crust. They don't forget about humidity either, because it's vital for this type of bee. Farmers often use special systems that slowly drip water from below, keeping the soil evenly moist at the right depth. This controlled environment creates the perfect spot for nesting, where each bee can dig its own burrow and lay eggs. As a result, the bees settle near alfalfa fields and start doing their main job, pollinating. Remember that pollinating alfalfa requires triggering a kind of mechanism, but ordinary honeybees often don't do this. Unlike other bees that learn to avoid the snap of the petals by taking nectar from the side of the flower without pollinating it, this bee doesn't dodge the mechanism. When it lands on the flower to gather nectar, its weight and movements create the pressure needed to trigger the mechanism. The stamens and pistils shoot with force, hitting the bee and covering its body with pollen. One well-established bee bed of about 1 acre can provide pollination for roughly 99 acres of alfalfa. This is a typical estimate often cited in agricultural studies. In practice, the coverage range is wider. In documented cases, one bed can effectively service anywhere from 99 to 197 acres under favorable conditions. In rare instances, farmers have reported servicing up to 593 acres thanks to a large, densely populated bed. Naturally, such high efficiency depends on many factors, yet the possibility alone clearly encourages many farmers. What farmers like most is the economic gain these beds can bring. When the man-made bee housing is working right, many farms see their total output go up by 10 to 30%, depending on soil salinity and other conditions. Now let's put this into money. Farmers say that 99 acres tended by bees can generate roughly $25,000 in extra revenue. 197 acres brings in about $50,000, and if we take those 593 acres, the earnings go up to $151,000. At the same time, preparing and maintaining a single bed is a relatively small investment compared to the income it brings in over tens of acres. So, for a very obvious reason, many farms and cooperatives invest in millions of bees right away to stabilize seed supplies and cut down on seasonal risks. Basically, Nomia melanderi bees can partly be called the reason why Nevada's alfalfa farming is thriving right now, and quite a few farmers actually want to switch to growing the crop for seed. However, it's not that simple, because using today's heroes can bring a lot of problems. These bees aren't very big, and they're not known for aggression that can scare off other animals, like what happens with wasps. As a result, this unique type of bee is very vulnerable to predators. For example, horned larks and other birds are very dangerous. They can easily gobble up huge numbers of bees because the insects are completely defenseless when they swarm out of their nests at certain times. One bird can swoop in and eat a large number of the main workers of alfalfa fields, so people need to try to somehow protect their buzzing little pets. For example, there's the practice of doing rounds during mass bee flights from the hives. At such times, a person can scare away incoming birds. It works, but not all that well. So there are better options. Special bird deterrents. Yes, it's an extra cost, but it's far better and more worthwhile than losing thousands of bees that bring in a solid income. And don't forget, these bees nest in the ground, so they're vulnerable to land predators. For example, skunks and badgers can dig up the soil in search of bee larvae. In many states, people have a complicated relationship with these animals. They're caught through hunting and traps. Besides that, bees are really vulnerable to parasites. For example, bee flies, one of the main pests according to studies, can reduce bee populations by 20 to 40%. A female bee fly hovers in the air above a bee's nest, then shoots tiny eggs into open holes or just into the soil nearby, and the number of these shots can be huge. A single female fly can lay up to 300 eggs a day. Once hatched, the fly larva is very active and starts looking for the entrance to the bee's nest if it didn't get in initially. Once inside, it finds one of the cells with a bee larva and food and then eats everything in its path. Pest control is very often carried out manually. Professionals recommend simply knocking down or crushing adult flies as they hover over the nests, particularly in the morning. Also, don't be surprised if you see a road sign with a strict speed limit somewhere near a field of alfalfa. That's probably what'll save both the pollinator population and the farmer's money. As we mentioned before, today's heroes are digging burrows in the soil. Machinery moving nearby can cause vibrations that compact the earth and even throw bees off. That's why researchers point to active roads near nests as one of the causes of population drops. But that's not all, because female Nomia melanderi bees remember visual and sound cues around their colony to get around. Loud noise, constant vibrations, and sudden changes in their surroundings can throw them off when they try to get back to their nests. Naturally, this also affects the bee population. Many other threats come from changes in the soil where bees make their nests. Not enough moisture can cause the nest to dry out and the offspring to die. If there's too much, for example from pouring rain, nests can flood or the risk of fungal diseases goes up. Finally, it's necessary to keep an eye on plant growth in the area where the bee house is located. Yes, the ground is covered with salt, mainly to keep weeds at bay, but there are salt-tolerant plants that can take over the beds and push out the bees. Looks like these bees come with too many problems. And that's even though there's a species that also handles alfalfa pollination and is way less picky about its home. These are leafcutter bees, named for their love of cutting little pieces of leaves for their nests. Like Nomia melanderi, unlike regular honeybees, they're solitary. Plus, leafcutters, just like the bees featured in today's video, can easily live underground. So why is this species less picky? The thing is, leafcutter bees don't dig in the ground at all, and they can use burrows made by other animals. Besides, this bee species can live in a tree or elsewhere. They don't really need to live underground. Actually, people take advantage of this low-maintenance lifestyle and provide leafcutters with special blocks to live in, not connected to the ground at all. As we've already said, this species handles pollination just as well as Nomia melanderi. They don't dodge the alfalfa mechanism, calmly take the hit, and then carry pollen to other plants. So this is a much easier to manage species that's just as effective at pollinating alfalfa. Because of their high efficiency and relative ease of handling, leafcutter bees are widely used in an industrial scale for alfalfa pollination, especially in the western parts of the US and Canada. Farmers buy cocoons with overwintering larvae, keep them in cold storage, and then when alfalfa starts to bloom, bring them out to the fields along with wooden blocks filled with tubes that serve as their nests. As a result, for example, in Western Canada, leafcutter bees are the main pollinator for alfalfa seed production, which makes them a key part of the local farming economy. That said, in Nevada's environment, relying on leafcutter bees may not be as effective as it looks. Unlike Nomia melanderi, which belong to this region and are already well known to farmers, leafcutters need to be constantly purchased, transported, and maintained in artificial conditions, which comes with steady costs. These costs make them less attractive than long-term efforts to set up bee beds for native bees. Moreover, studies show that Nomia melanderi perfectly adapted to the local climate and soils, displaying outstanding productivity, which makes them unmatched in both efficiency and cost-effectiveness, specifically in Nevada. Turns out these very bees are the perfect choice for Nevada, despite all the challenges farmers face in setting up bee beds and keeping them in good shape. Now just imagine, after a while, maybe alfalfa farmers won't be using the economically efficient, but still very demanding bees anymore, and instead they'll turn to something that doesn't need anything at all. Yes, that's right, robots. Pollination robots are indeed in the works. One of the newest is PolliPlus by Aruga AI Farming. It's an autonomous system powered by artificial intelligence and machine vision, allowing it to navigate rows of plants and detect flowers that are ready to be pollinated. According to the company, using PolliPlus can boost yields by 5 to 20% compared to other methods. The robot's also equipped with cameras that collect valuable data on each plant as it works, helping farmers track their health and spot problems in time. This technology is already being used successfully in commercial greenhouses in different countries around the world, and a single operator can control an entire fleet of such devices, capable of pollinating up to 2.5 acres of plants. However, as you can see from the company's footage, the solution is designed only for greenhouses and won't work for alfalfa fields. First, most likely, out in the open, the invention just won't function. Rain, wind, and other natural elements would get in the way. Second, it would simply take far too long to pollinate the hundreds of acres of alfalfa grown in Nevada. And third, this method of pollination is absolutely unsuitable for the crop we've been talking about today. The thing is, the main goal of PolliPlus is to mimic buzz pollination, which in nature is handled by bumblebees. Instead of physically touching the flower, PolliPlus uses a compressed air mechanism. The robot creates high-frequency pulses that make the flower vibrate and shake out its pollen. This works fine for tomatoes, but alfalfa has a completely different pollination mechanism, so just blowing air won't cut it. There's, for example, the bionic bee from Festo, and this is something that, at least in theory, could replace bees. The bionic bee can fly and maneuver on its own, and that's exactly what's needed for pollination. Plus, it's small and lightweight, which lets it move around among plants. In theory, the robot could be equipped with a mechanism that would mimic the physical pressure needed to pollinate alfalfa. Still, this robot's nowhere near a practical application. Bionic Bee is a research prototype, not something made for the market. Its use in open fields doesn't make sense given the huge scale. Pollinating hundreds of acres would take millions of such devices, and the overall cost would far exceed creating bee beds. Besides, the robot can't cope with unpredictable weather like wind and rain. So let's leave robots for later. For now, Nevada's farmers rely on real live bees.